say more faster.
We'll say hello to Android. Thanks, Christina. Awesome intro. So we're going to go to the similar level of depth. We're just going to see your Hello World example to demonstrate the tools. And after the break, we'll do all 4 platforms again with the more in-depth API examples. So what are you going to see in Hello World? The tools, which follow the usual edit, build, run, debug cycle, that loop. We're going to look at the loop. We're going to look at the core activity class, which is the counterpart to the view that you just saw for the Apple case. We're going to look at the source and resource files in the editor, in the Eclipse editor. And we're going to look at the application manifest, which is the counterpart to, what is it called on iOS?
Info-plist.
Yeah.
Sorry?
Info.plist.
Info.plist. And ours in Android is called the application manifest.apk or .xml. It's an XML file. Here's your cycle. Edit, build, run, debug. We all go through it every day, possibly hundreds of times. It has to be as fast as possible. We do it in Android using Eclipse, integrated development environment. Java is our target. So we do it both develop and target on Java. We run on either an emulator, like what you saw in the Apple case, or hardware, real hardware, connected to a USB device. And we debug using the Eclipse debugger interface, but you can also use other debugger interfaces. I've never seen them, but you can also use other debugger interfaces. So they're your basic tool sets. They run on all 3 platforms, all 3 major development platforms that you can get these 2 on. So Windows, Mac, or Linux. We've been through out of the box. Edit. Here's our hierarchy. I'm going to switch. Can you folks see the hierarchy on the screen there, the display? Probably not.
Small.
In fact, it's too small. So we'll look at it on the big screen instead. Pre-canned. Who here has developed in Java? Who has not? Okay, quite a few. It's a strongly typed language, which gives you great integration with your documentation system, your autofill, your autocomplete. Here's your basic hierarchy. You've got your source files. I've got multiple projects open here. Hello World is the one that I'm currently looking at. It's got a main.java activity source file, some supporting resource files that we'll look at in a second. That main activity's got an activity. This is your counterpart to a view, like what we just saw in the Apple case. And it has an onCreate, which will populate its view with a declarative description, an XML description of the view, which we'll see in a minute. And then if I'm running, I'll see my output down here on my console and my log displays.
So which view is an activity?
Yeah, well, there's a distinction between an activity, which is a container for a view. Your activity is, strictly speaking, your controller, and then your view is a view, that's controlled by the activity class. Yeah. Then we build. After we edit our source, we build. We can ask for it to happen automatically, which turns it into a simple shortcut, Alt-R. We'll run. When it builds, it creates an APK. This is your target file, .apk. It has everything in it that it needs to run on the target. Your resource files, your drawables, for example, your runtime Java code, your bytecode, and some manifest information, search to assign the app so that it authorizes the author, that kind of thing. There's your hello world.apk. You can unzip .l to get the contents. That's how I get the contents. That's what goes to the target. When it runs, you choose a target, being your emulator. Here I've got Froyo set up as Android 2.2 target. If I had a piece of hardware connected to it, it would also show there. My tablet or phone can plug in by USB. I can configure those targets according to my display resolution, memory, storage, SD, wireless interface, that kind of thing. When it runs, it looks like this. You've got your hardware buttons on the right and your view on the left. Different from the Apple, which is why I asked whether it was native on the Apple case. This runs slow. This is an ARM being emulated on x86. Unless I understand, I've just learned, that you can get a native for x86. With more recent BIOSes and that emulation mode on your x86 target, you can run the emulator target native to x86. So there's hope as far as the emulator is concerned. But a piece of advice, get a real piece of hardware to target. Because that edit, run, debug loop has to be as tight as possible, and it's much, much faster on real hardware, let alone your differences in peripherals, which is worth itself, worth the hardware itself. And these are cheap, like what's a Nexus tablet, $200-300. And that's your entry level, that's your cost. It's any x86 development host and a device. You're done. No permissions, no sign up, no license, no annual renewal, just go to town. Okay, so when we debug, what we're doing is communicating between the host, which is this side roughly, and a client that runs on the target here. We call it the ADDM, something like that. And I can target real hardware or the emulator, and the same debugger runs on both, which is really nice. Here's the debugger view. I had set a breakpoint on create. I ran the app. It stopped at this point, showed me the current trace point, showed me the state of the variables. I can inspect any variable. There'd be a breakpoint list, and that lets me determine the state of the processor at that point that I asked for the breakpoint, and I can single step through like you'd expect any debugger and inspect the variables. Nice little tool. There's a lot of adjunct debugging tools. This is one I wanted to bring your attention to. This here shows the processing stack in the level of hierarchy. Here's my CPU 0. These are where the clock cycles are going. And I can see dropouts. If I've suspended the main thread too long, I've suspended the refresh rate, and I'll get a jittery UI. So I can debug my performance very handily using the systrace debugging tool, which is excellent tool. Only targeting the latest hardware, but once you debug your performance, that same performance would be back compatible to your other devices. So great little tool. Now, that was a tour of the tools. Now we're going to see the basics of an application. If you remember anything about Android, how to develop on Android, it's this state machine. Stephanie asked us, what's the difference between an activity and a view? An activity is a controller for your view. This is the controller state machine. It's not running, it's just got started. It goes through a series of startup events, create, start, resume. Here it's visible to the user, so now my activities view is visible to the user. It could get paused by another app coming in on top of it. So here's your paused event. It could get stopped. It's actually stopped. It's on its way to getting kicked off the processor stack. And then on destroy, it's actually destroyed. That process is gone. That activity is gone. After it's suspended, it could be resumed. An app came on top and then left. My app comes back to the top. It just got resumed. Or it could be killed suddenly if we run out of resources. So here's the thread, the state transition to go back to destroyed because of the memory of resources. Yeah.
So would an app just have a single activity then, or could an app have multiple?
An app comprises multiple activities which will act cooperatively. They all run in the same thread. This is the state machine for a given activity. So an application comprises a set of activities which come together to do a useful task. So let's cook one up. I want an app that takes pictures, it tags it to a map, and then emails it out to my friends. So that would comprise, that's a single app, say, and it's got 3 activities. The camera activity, snap. The map activity, come in and put a pin on a map, get the geolocation tag off of that. And the third activity, send it to my friends. Call, send mail to friends, or send mail to target. So that's a single app with 3 activities to accomplish a task, which is to send a geolocation tagged image to my friends. Sound good? We just looked at activity here so far, because that's as much as you need for Hello World. This is more detail than you really need. Really, you only populate on create. And here's what it does. My main activity extends the superclass activity, which is supplied by your SDK. And then I set my view to be the activity main view, which is an XML file to describe the layout of that view. And here's that layout. It's a text view with a string here called Hello World, which I've defined in another resource. My resources file, strings.xml, defines the Hello World string to be the string Hello World. So there we've seen 3 source files so far. The, whoops, how did we get there? The Java source, which is the controller, looks like that, with its population. Let's not get too out of order here. Java source file. There it is, Java source file. Refers to the layout XML. There's my layout, defines the view, makes reference to a string resource. There's my third file, a string file, defines the actual string that gets populated into that widget. All of those three pieces are wrapped together using my manifest. This defines my application overall. It is an application with a single activity that contains the .main activity Java class, and it's initiated by this action or intent. In other words, you'll hear in Android circles is an intent. It satisfies the launching intent. So the system says, load the app, look for the launch intent, run the class that corresponds to that intent. So that activity will start up. And implicit in this as well is your resource files that get bundled. And it defines your minimum runtime target, like what you saw in the Apple case. This is what I need for a minimum SDK. I'm going to actually target 8. That's about it. And this is version 1.0 of my app. So the APK also controls the version numbering for the application as it goes into the store and gets distributed, that kind of thing. Any questions?
What was that you said about speeding up the emulator?
Speeding up the emulator. Can you tell us, Jay, you know more about it? Have you used it?
We need to download and install Intel Hardware Acceleration Manager. So that is a tool provided by Intel. Then you also need to download the Atom image. So in that case, your emulator is like running on the Atom-based hardware. So that will be speeding up the simulator.
Okay, so if I want to Google this, what am I going to Google?
Sorry?
If I'm going to Google this, what do I Google?
You Google Android Intel Hardware Acceleration.
So can I ask a question, Jay, real quick? Is that so? Do you have to have an Atom machine to run that on, or will it run on any x86?
It's a x86, a regular computer, but you have the Atom image downloaded into the Android SDK.
Oh, okay.
And you create a new virtual device based on that image.
I see, because it's then you're matching.
Right.
I see, yeah, okay.
So there's two innovations involved there. An Atom target for Android. Android normally targets ARM on the ARM processor, so it's an Atom target Android image. And a laptop that will support Intel accelerated hardware. Or Intel, what would the phrase be?
Your computer must support the Intel hardware virtualization technology. So usually that is one option that you can set up in your BIOS. All the computers do not support that.
Mine doesn't have it.
The other thing is the Apple running natively, or has she just got really fast hardware?
No, the simulator.
No,
has
the simulators,
faster.
yeah, it's and the simulator on iOS is faster than a physical device. The debugger slows down a physical device when you're running it from hooked into the debugger. It is faster to debug in the simulator.
Can I answer that question? I'm not going to videotape myself. Because they've actually implemented it's not an emulator, it's a simulator.
Yeah.
Right? So it's actually all implemented in OS 10 technology.
Yeah, cool.
So they've done a very good job though, and it really is almost identical. It's just not 100%, but it means you get great speed.
Yeah, totally.
But yeah, it does mean there are two SDKs technically.
Yeah, and you cannot take a build that's built for that and run it on a device. It's just completely the wrong platform.
And if you're counting on like that speed, like if you're doing a game or something, you want to make sure you test it on a real device to make sure that it's still running quick enough. Because it might look great on the simulator, but then on the device it might crawl.
Yeah, for sure.
But don't trust the device speed if the debugger is running.
Yes.
Let's take Scott. BlackBerry's up.